Hello, welcome to the second Canary Designs video. At the end of the first video, we promised to show you how to build a digital environment. Now, as ergonomists, we have to be able to work with these models, and we then bring in the digital human model with the CAD model, and we can start looking at those interactions. So in this video, I'm going to hand over to Gary Guan, and he will take you through the process to build your own digital environment. Okay, over to you, Gary.
Thanks, John. So you all might be wondering, so what is a digital environment? So in front of me, I've got some examples. So right now, we're looking at a chroming facility. So it's a massive facility. You can see these models, they come in all shapes and sizes. Next, we've got a pallet pump truck. Next one, we've got a bigger Airbus aircraft. Next, we've got an injection molding machine. And lastly, it's an office environment. So you can see the diversity of these models. They come in all shapes and sizes depending on what you're designing for and what you're working with. So you've seen a variety of different digital environments. So let's have a look at how you can create your own. So we always start with the big question: does the client have a CAD model? And if they do, which is quite likely in this day and age, as more businesses and companies move to computer-aided design, then we'd request it in a step file format. So that means that it doesn't matter whether you're in SolidWorks, Autodesk, or any other CAD software, as long as it exports in a step file format, we can use it. Alternatively, if you don't have a CAD model, then there are a few different options we can use to create a digital environment for you. So one of them is physically measuring it and making it ourselves. Another is 3D scanning. And the third is using the internet. So browse for the standard components and then build up your digital environment from that. And the end result is to have a CAD model which we can use. So let's have a look at what each of these different routes involve. Looking at the different option when physically measuring the environment that you're trying to capture, it involves using physical tape measures, vernier calipers, or any other tools to measure and note down all the dimensions of it to recreate it digitally. So it's great for simple forms like tables, shelves, and other simple geometric shapes. But when looking at more complex forms like sculptures or anything quite fine in detail, you wouldn't choose to use this process as the accuracy isn't great and the time you have to invest is quite high. Because after you've measured it all, you have to use a CAD software to recreate it again. So when looking at 3D scanning, the process is a lot quicker in comparison to physically measuring it. It's great for quite complex forms as the accuracy is quite high. You can do difficult shapes, you can do a whole facility. Once you've got the 3D scan completed, you do need to do some post-processing, so using software in order to fill out any gaps in the scan that you've got, and then importing it into SolidWorks or the CAD softwares, which you can then export as a step so that we can use it. So when looking at online resources, there are a whole host of databases which you can use to get them. It is a growing resource as it's open source. As more and more people begin to use CAD, there'll be more on these websites. These are just only a handful that I'm aware of. I'm sure there'll be plenty more out there. So we're just going to show you a quick example with 3D Content Central. So it's a SolidWorks platform, and we're looking for GoPro Hero 5. So just to show you how simple it is, you search for it and you find which one you want, and lucky enough for us, the supplier is actually GoPro, so we know it's dimensionally accurate. And then you can see the preview on the left, and all you have to do after that is click configure and download and enter your details. So that's a quick tour of all the 3 different methods we can use to create a digital environment if you don't already have a CAD model on hand. But selecting which of these 3 methods to use, we have some criteria that help us. So time, so how much time you have to do to create this room and product digitally. How difficult is it? Is it quite high in detail, or is it just big? The accuracy, so how accurate do you need a digital model to be? So that might vary from case to case. And how much budget the client wants to set aside to create a digital replica of the environment. So for instance, a facility you wouldn't physically measure. and you wouldn't necessarily be able to download it from the internet. So in that case, you'd use 3D scanning, and as it's quicker and it's able to have a higher degree of accuracy and more suitable for such a big area, whereas physically measuring, it'll take you a lot longer and it won't be as accurate, yet it might cost more because it will take longer. So those are all factors to consider when choosing which route you want to go down when creating a digital environment when you don't have a CAD model. So we've looked at all the different methods you can use to create a digital environment. So hopefully by this stage, regardless of which method you use, you have a CAD model. So what you're looking at is an example model we have from a case study. So this is for a client who is a wheelchair user with limited mobility, and they wish to take photographs of events which they attend. So we designed this camera attachment for their wheelchair. So the wheelchair and the tripod sections and the camera, they're all downloaded from the internet, and it's only this black section here which was custom fabricated for the client. All these models weren't dimensionally accurate, so during the site visit, the wheelchair for the client, the wheelchair dimensions were taken along with the tripod. So the tripod, we had one in the office which we wanted to use, and we just took all the measurements from that and adjusted the CAD models which we downloaded accordingly. So we have a dimensionally accurate digital model. So this model is ready to export into JAC, but we need to go convert it as into a step file before going into JT, as JAC only accepts JTs and SolidWorks doesn't export in the JT format. It's always worth considering the joint movements which you want in the JAC assembly. So I want to be able to move this bar up and down, and this camera section, handle section, pan up and down. You can do all that if you export this as a single step file, open it up in JAC, and using the joint manipulation features, but I find it a lot easier personally just to do export all these parts as individually and then just put them into JAC one by one. So as this is in assembly mode, I can suppress and hide all the components which I don't want to show in my part which I'm trying to export. In this case, I'm going to export this camera and handle section. So if I highlight all of these sections and suppress, they'll all be hidden, including this bar section, as I need that to rotate differently. So you can like that. So you'll be left with 4 parts which make up the single part which I want in JAC. So you can go File, Save As. You can save this straight away as a step AP214 file, but I find it easier to save it as a step SolidWorks part first. The only reason being, if you save it as a step now, when you open it up in JAC, things might move around because of the mating that I use to create it in SolidWorks. So if you save it as a part and you switch over, so this is saved as a part now, you can tell with the solids here rather than the feature tree with all the parts that make it up. And you go File, Save As, and then you can convert that into step AP214, and then that'll be ready to open up in Teamcenter. So you'd hit save, but I've prepared a step file already for this video, so I can hit cancel, go ahead and minimize SolidWorks, and click to open up Teamcenter. So Teamcenter is another Siemens product, and it's what we're going to use to convert that step file we just saved in SolidWorks through to a JT file. So once it's open, you can go to the top and click open and navigate through to find the step file which we saved earlier. So ours is just there, step. So you can, it does take a little while to load up depending on the file size, but once it's open, you can see there, you can check all the services are intact and click File, Convert Model. You find that model step file again, you click open and you give it a new name, and you can see it saves it as a JT there, and hit save, and it's as easy as that. So once you've converted the step file into JT and have it all saved in Teamcenter, you can go right ahead and power up JAC like I've done here, and I'll create a new scene. So we just go File, Open to bring a JT file in. So in this case, it's the GoPro I'll do first. .jt, so it's the right one. You can filter it if you've got loads of different files, but and we managed to find ours right here. So hit open, it'll bring it straight into the scene. So everything's okay, but if I just try to quickly rotate it, you can see the center of rotation has shifted, it's offset a little bit. So the first thing I like to do is try and get that fixed. So we switch to site mode, go to object, create, site, select the segment which is there, and go set location. So what we're doing here is essentially setting where the new axis of rotation is for this part or segment. So if I roughly move that around to there, it's roughly where I want it to be. If I hit visible, so that makes it easy for us to see. Also, it's worth making a note of the name, like anything with CAD. So S0, so just remember that. Hit create now. So it's got that red X, Y, and Z axes there, showing where it is. If I switch back to figure mode, go to properties, right click properties, and click there, you can see sites. So if we click drop down menu, there we go, S0, that's the site we just created. Set route, that'll change the route sites there, and hit apply, dismiss, and if I select that now and try to rotate it, you can see the center of rotation has moved. So it's a really useful little trick to have, especially if you've got multiple parts that are coming into the model, like this model, this scene that I'll be showing you next. So now that you have seen the process of how to import a JC file into Jack, I'm going to repeat it for all the other parts in the SolidWorks assembly which you previously saw to recreate the environment in Jack. The digital version of me makes another appearance in a seated posture, and in the next video we'll be looking at how to simulate real-life tasks in a dynamic environment digitally. So now that we have reached the end of this video, it's a good time to recap on the content which we've covered. So in the first section of the video, we looked at how to acquire CAD data. So that includes the three methods which we can use, and the factors you should consider when choosing which is the most appropriate method for the digital environment you're trying to create. Then we looked at how to build an assembly. So that looks at identifying all the different parts in an assembly and the relationships between each other. In our case, it was SolidWorks, before exporting it as a step, and how to translate that step into a JT file. And the last section of the video looked at how to prepare it for digital human modeling, which is in Jack. So how to check and manipulate any properties of parts which you've imported into Jack, and how to build a scene. So that's the end of this video. So thank you very much for watching, and I hope to see you in the next video.